Hi everyone. Today we're going to talk about factoring some more. We're going to factor trinomials where the a value equals 1, and then we're going to talk about perfect square trinomials. Before we get to the essential question, I want to talk about what it means when a equals 1. So your standard form of a trinomial is ax squared plus bx plus c, and it should equal 0, or perhaps it doesn't equal anything. Perhaps you just have the ax squared plus bx plus c. A, b, and c are supposed to be coefficients and a constant, so they're actually supposed to be numbers. And what we're talking about here when we factor trinomials where a equals 1 is we're talking about this a value right here being 1. So when you see a polynomial that has an a value of 1 that looks like just x squared plus something x plus something. And it could have the equal 0. And the little blanks might have numbers filled in. But what we're talking about is that first term being 1x squared or just x squared. So I just wanted to point that out to you, that those are what our polynomials look like whenever we have a equals 1. The first essential question is, how do we factor trinomials that have an a value of 1? And because our notes have a second section on perfect square trinomials, our second essential question is, what is a perfect square trinomial and how do we factor it? Okay, so I'm going to scroll down in my notes, and we're going to start out with factoring trinomials when a equals 1. So we're going to answer that first essential question at the beginning of our notes. So if I want to factor, the first thing I want to do is factor out the GCF. I always want to look to see if there's a GCF that can be taken out. If the GCF is 1, then that really doesn't mean I can take anything out. I just move on to step 2. Step 2, whenever I am looking at my polynomial with a equal to 1, I need to find two numbers that multiply to equal a times c. So the first number times the first number times the last number, and they need to add to be the b term, so that middle term. And it's kind of easy to remember that the multiplication numbers need to equal a times c, a multiplied by c. So that's how I remember, is that the numbers need to multiply to give you the product of a and c. So the multiplying kind of goes together. And then finally, you need to write as two binomials, so either x plus a number or x minus a number. And then the second factor as well, x plus a number or x minus a number. There are some hints if you're having trouble figuring out the signs, because sometimes the signs are a little tricky. So I'm going to go ahead and scroll this up, and then we're going to look at our first few examples. We need to factor completely. So number 1, the way you say this problem is x squared plus 4x minus 12. I'm just going to write my standard form on top just so that you're aware of what is in what place. So ax squared, that's really 1x squared. That means my a value is 1. Bx is 4x, so my b value is 4. And the plus c is really a minus 12, so the c value is negative 12. So I need to multiply two numbers, or find two numbers that multiply to give me a times c. 1 times negative 12 is negative 12. Those same two numbers need to add to give me the middle term, which has a 4. So I need to think to myself, what two numbers multiply to give me just 12 at first? So I'd list out to the side starting with 1. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And if I go to 4 times 3 is 12, and that's just a repeat of the previous pair of terms, so that means that I'm done listing my terms. Now, if my multiplication target number, my negative 12, if it's negative, that means that one of the numbers in my pair will also be negative. So I kind of need to find two numbers that have a difference of 4 instead of a sum of 4. Well, 1 and 12 are not 4 units apart, so that's not going to work. 3 and 4 are not 4 units apart. That's not going to work. But 2 and 6 are 4 units apart. So 2 and 6 are my numbers, and I'm going to have to kind of doctor up the signs here. So look at your 2 plus 6 equals 4 portion of your problem. 2 plus 6 obviously does not equal 4. But if I make one of those numbers, 2 or 6, negative, then the result will have to be 4. If 4 is a positive number, that means that there are more positives left over. So I need to leave the bigger number, the 6, I need to leave that positive, and I need to make the 2 negative. So when I create my two binomials, the first one will have an x at the beginning and then a minus 2, because that's my first kind of magic number. And then the second binomial will have an x at the beginning and then a plus 6 for my second magic number. And this is my factored form of x squared plus 4x minus 12. Okay, let's move on to the second problem. I want to go ahead and identify A and B and C. So let's see if you can do that on your own. I have a 1, a negative 9, and a 20. I also notice that there's no GCF that I can take out, so that means 1, negative 9, and 20 are the numbers that I'll be working with. I need to find my magic numbers, so two numbers that multiply to give me A times C. 1 times 20 is 20. Those same two numbers need to add to give me the middle number, which is negative 9. So I'm going to list my factors of 20, things that multiply to give me 20. So 1 times 20, 2 times 10, 3 times nothing, 4 times 5. And if I go to 5, that'd be 5 times 4, and that's just the same pair of factors as the previous two flipped around. So I need two numbers that multiply to give me 20. All of these do, but they need to add to give me negative 9. Well, if they add to give me a negative number, but they multiply to give me a positive number, then that means they're going to have the same sign. And here they're going to have to be negative. So my two numbers that work are 4 and 5. However, 4 plus 5 is not negative 9. 4 plus 5 is positive 9. So I need to change my signs. And when I create my binomials, the first one is x with the first magic number, which is negative 4. And the second one is x with the second magic number, which is negative 5. It does not matter if you have it in this order or if you have it in this order. Either one is acceptable, just so long as you have x minus 4 as a factor and x minus 5 as a factor. So we have some practice problems here. In fact, we have 5 practice problems before we go on to the next type of problem. So I'm going to do number 3 and number 5. You are going to do number 4 and number 6. So look at number 3, 2x squared plus 4x minus 30. I notice that both 2 and 4 and 30 also, they're all divisible by 2. So I'm going to take out a GCF of 2 that's going to hang out in the front of my problem until the very end. Now what's left over, 2x squared divided by 2 is just x squared. 4x divided by 2 is 2x, and negative 30 divided by 2 is negative 15. So I'm going to look for my A term, my B term, my C term. A is 1, B is 2, and c is negative 15. Don't forget to include your signs. So my magic numbers, are two numbers that multiply to give me negative 15, but they add to give me 2. So let's list the factors of 15. 1 times 15, 2 times nothing, 3 times 5, 4 times nothing, and then 5 times 3 just repeats. So my pair that works are 3 and 5. However, if the product is negative, one of my numbers needs to be negative. If I look at my second equation, my sum is positive 2, which means that the positive number needs to be the bigger number. So I'm going to leave 5 positive, I'm going to make 3 negative. So now I continue to bring down my GCF. It's still part of the problem. But then my factors are x minus 3 and x plus 5. The GCF 2 is also a factor. It is the greatest common factor that we took out at the beginning. So truthfully, number 3 has 3 factors. It has 2, it has x minus 3, and it has x plus 5. So what I'd like for you to do is pause your video and try number 4 on your own. Check back whenever you think you have the answer. And if you make a mistake, you're welcome to change it. So check your number 4 with my number 4. Make sure your A, B, and C value are accurate. Make sure your target numbers are 72 and negative 18. If you missed the magic numbers, negative 6 and negative 12, perhaps you need to practice writing out your factors. So numbers that multiply to give you 72. 1 times 72. 2 times, well, if you don't know that 36 is what you multiply 2 by to get 72, then maybe you should type into a calculator 72 divided by 2 and then see if you get a whole number. If you do, then that's what goes here, and you have 2 nice pretty factors. Occasionally, for example, right here, if you take 72 and you divide it by 5 to try and see if 5 times something is 72, you're going to get a decimal, which means that 5 does not go into 72 nice and evenly. So you skip 5 and you go on to 6. So that's the way that I'm checking my factors. You are welcome to use a calculator to type in and do 72 divided by a number to see if you get those factors. Okay, let's talk about number 5. Number 5 looks a little crazy, but we're going to ignore all of the variables and exponents that are there right now. We're just going to focus on the numbers. My A value is 1, my B value is negative 5, and my C value is negative 24. So I'm going to find my magic numbers. Something times something equals negative 24, and something plus something equals negative 5. My factors of 24, I'm just doing 24, not negative 24 right now, are 1 times 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24, 5 times nothing is 24, and then 6 times 4, we're right back at that last factor. So I'm finished listing my factors. I need a pair that multiply to give me negative 24. So all of these do if I make one of them negative. But then I need them to have kind of a difference of 5 because their sum has to be negative 5. So that would be these two right here. They're 5 units apart. So 3 and 8, 3 and 8. And now I need to decide which one is negative. My sum is negative 5, which means there should be more negatives left over, and my bigger number should be the negative number. So notice whenever I write my answer, I'm going to leave a little bit of space between all of my terms. And the reason why is because I've got to put in some extra variables and exponents. So I have x plus 3. I have x, oh no, not plus, hang on, minus, because that was a negative 8, minus 8. Okay, so remember that factoring and foiling or doing the box method, those are both related. They're kind of inverses of each other. They're opposites of each other. So if I were to take this answer that I have right now and foil it, I want my problem back. But I'm not going to get it because I don't have any y's and I don't have enough x's. But I do notice that I've got just a regular old 24, minus 24 right here. And when I multiply 3 times negative 8, I do get negative 24. So those last two terms need to stay exactly the way they are, because just the way they are, they're giving me negative 24. Now, my first two terms, when I multiply them, should give me x to the 4th y squared. And they need to be the same type of term, which means that I kind of need to divide those exponents in half and give half of them to the first term right here and half of them to the second term right here. So x to the power of 4, if I divide 4 in half, that's x to the power of 2. And notice that if I multiply x squared times x squared, I get x to the power of 4. Now the other thing that's missing is y squared. Well, if I divide the exponent of y squared by 2, I just get y. And notice that y times y is y squared. So now I have a problem that if I FOIL it back, I will get my original problem. So I'm going to ask you to try number 6. Number 6 is a little tricky because it's got that extra variable in it. For right now, just focus on the numbers like we did at the beginning. And then at the end, you can see if you can fill in the right variables in the right spots to make the full complete answer. So pause your video and try number 6. So on number 6, my magic numbers are -4 and +7. -4 plus 7 is a +3, so that's how I knew to put the negative with the 4, because the sum was positive. So now I need to figure out where this y goes. I notice that if I were to FOIL this answer back, x times x is x squared, and that is my first term of my answer, which is good. But my last term is -28y squared. So -4 times 7 does give me -28, but I need it to also have the y squared with it. So the exponent of y squared is 2. If I divide it in half, that's 1. So that's a y to the power of 1 and a y to the power of 1, kind of tacked on to the -4 and the 7. So now if I multiply -4y times 7y, I get -28y squared, and that matches what I'm supposed to have for my problem. Okay, so I'm going to move down to the next type of problem. Oh, I'm sorry, I forgot number 7. Go ahead and pause your video, see if you can try number 7 on your own. Okay, did you remember that your leading coefficient, your x squared coefficient, at the beginning couldn't be negative? That's from our GCF notes. So if your leading coefficient was negative, you had to at least divide out a -1 for the GCF, which makes its way all the way down into the final answer of our problem. Now it is also possible just to have a negative in front of your two binomials, also called your two linear factors. That's acceptable as well. When you deal with 5s and 6s in your polynomial when you're trying to factor, a lot of times students struggle with trying to decide if they should use 1 and 6 or 2 and 3. The thing that makes you be able to make the right decision is looking at the signs. So obviously 1 times 6 is 6 and 2 times 3 is also 6, but if the sum is -5, well, the only way for the sum to be -5 using 1 and 6 is if the 6 is negative. But when you multiply those back together, you end up with a -6 for the product, and we don't have that. So that's how I know that the 2 and the 3 should work, because -2 plus -3 is -5, but if I multiply them, I still get the +6 for my target number. So that's how I know to go with the 2 and 3 versus the 1 and the 6. Okay, so let's go down and answer our second essential question today. We're going to talk about factoring perfect square trinomials. We still have standard form with ax squared plus bx plus c. You always want to look for the GCF first. This is going to be really common in our notes. You're going to see that step 1 is to factor out the GCF. But a perfect square trinomial is exactly what it sounds like. Trinomial means 3 terms, and perfect square means that it's got 2 perfect squares in it. The first term must be a perfect square. The last term must also be a perfect square. And since it's a trinomial, there's a middle term, and the middle term must be the square root of the first term times the square root of a second term, and then doubled, so 2 times. And I'll show you what that looks like in example 1. So example 1, there's no GCF. I can't divide 4 and 12 and 9 by anything for all 3 of them. So I'm going to skip to step 2. Step 2 is to determine if your first term is a perfect square. So can you square root 4 and x squared? Absolutely. What's the square root of 4? 2. What's the square root of x squared? X. So 2x times 2x is 4x squared. So we do have a perfect square for our first term. Third term, last term, also needs to be a perfect square. So if you square root 9, do you get nice pretty numbers? You do. This is 3 times 3. Now this last thing, this middle term must be 2 times the square root of the first term times the square root of the last term. It doesn't seem to make a lot of sense in the steps, the way that it's written. However, if I were to take 2x times 3 and double it, I should get this term right here. So 2x times 3 is 6x, right? And if you double 6x, you get 12x. So this is a perfect square trinomial. The way that you write your answer is one of the first factors, one of the second factors, so 2x and a 3. You use this sign right here because either you can have positive 3 times positive 3, or you can have negative 3 times negative 3, and that still gives you a 9. So we're going to use this middle sign right here, and there are 2 of them, 2x plus 3 times 2x plus 3. It's the same 2 factors, but we write this as 2x plus 3 squared. So this is your final factored form for number 1. Okay. So we're going to break this up into steps. First step. Is this a trinomial? Yes, it's got 3 terms. Is the first term a perfect square? Can you square root it and get something nice and pretty? Yes. The square root of 36 is 6. The square root of x squared is x. So that works out nicely. Is the last term a perfect square? Yes. 5 squared is 25. If you take a 6x and a 5 and you multiply them together, what do you get? You get 30x. Now double it. Do you get that middle term? You do. 30x times 2 is 60x. So in order to write my final answer, I'm going to take one of my pieces here, one of my pieces here. I'm going to use this sign, so 6x plus 5. And there's 2 of them. They're the same 2 factors, so I write the sum of 6x and 5, and I square it. Last problem. Now I know right off the bat that 98 is not a perfect square, but I notice that the ending digits here are an 8 and a 6 and an 8. So all three of those terms are divisible by 2 because they're all even. So I have checked for a GCF and I've determined that there is one, and it's 2. So 288 divided by 2 is 144. That's looking good because you know that's a perfect square. Negative 336 divided by 2. Well, that's not as easy to do in my head, but if I typed it in, I would get negative 168 x's. And then 98 divided by 2 is 49, which is also looking good because 49 is a perfect square. So if I square root the first term and the last term, and I check the middle term, then I can do my perfect square trinomial. So I'm going to pause the video and see if you can finish writing your final answer. Pause your video. So if you're finished with your problem, you can check your answer with mine. Make sure that the GCF of 2 makes an appearance in your answer. This is a wonderful example of why you take the middle sign to use in your binomial. Because 49, if I square root it, I get plus or minus 7. We talked about that in the last set of notes. So either positive 7 times positive 7 will work, or negative 7 times negative 7 will work. And if I'm trying to match this middle term, and I take 12x and 7 and multiply them and then double it, 12x times 7. Well, 12x times 7 is 84x. And if I double it, I get 168x. But I don't want 168x. I want negative 168x. So the only thing that can fix this is making the 7's negative. And that will give me the middle term that I need, which is why this negative appears in my answer.